Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 18 of our complete DevOps course, and in this video we'll be talking about CI/CD. Yeah, so this is one of the videos that is most asked from the day we are doing day 0. Everybody has been asking about CI/CD. Like I get a lot of comment requests asking, okay, can you please do a video on CI/CD? Although I have done a couple of videos on CI/CD, if you watch or if you take a look at my channel, so there is a basic CI/CD setup that I've explained, or also I've explained about a complicated or advanced CI/CD setup, but it's fine. I mean, as part of this 45 days of DevOps course, we should also talk about CI/CD, where we will try to understand what is CI/CD. We'll introduce ourselves to the world of CI/CD. What are the different tools that are part of this CI/CD, and we'll also take a look at couple of projects. Okay, so when I'm talking about the projects, I'll show you what is a basic CI/CD setup that people were using 5 years ago, or what is a legacy CI/CD setup, and how this modern day applications, like for example, we have modern day applications like Kubernetes. Kubernetes is a project, right? Amazon or Flipkart. So how these people are doing CI/CD? Okay, because the legacy CI/CD setup is not scalable, so there has to be a modern day solution, and we'll talk about the modern day solutions for CI/CD as well. Okay, now before going there, what we should understand is what is CI/CD, right? Because there are many people on our channel who might not understand what is CI/CD. So for them, if I just try to explain CI/CD very quickly, CI/CD is basically two steps, right? One is continuous integration, and the second thing is continuous delivery. Okay, so there are two parts to CI/CD. So continuous integration is a process where you integrate a set of tools, or you integrate set of processes that you follow before delivering your application to your customer. And continuous delivery is a process where you deploy your application, or you deliver your application on a specific platform to your customer, for example. Okay, so this is a textbook definition. Now let's try to understand this using a practical or real-time example. You have your application. Let's say you are an application developer and you have developed your application on your personal laptop, and your customer is sitting somewhere in the USA or Europe or some other part of the world, and you are sitting in a different part of the world, let's say. Okay, so how your application is delivered from your personal laptop to the customer who is sitting in a different part of world. So this process, okay, every organization goes through this, right? Whether it's a startup, whether it's MNC, or whether it is MAN companies, everyone has customers over the globe, and your application has to be delivered to your customer in a prompt, or in a efficient and reliable way. That is, your application has to be tested, right? Your application has to be scanned for any security vulnerabilities. Your application has to be there has to be reports which suggest that okay, everything is perfect with respect to your application. Finally, you deploy your application somewhere which your customer will be able to access. So these are certain steps, like for example, these are the steps that I explained you. And from customer to customer, or from uh, product to product, these steps might vary. Let's say you are a mobile application, these steps might increase or decrease. Okay, let's say you are a web-based application, or your application is very secure, you are dealing with some government project or something. So these steps might increase or decrease depending upon your application, but in general, there has to be a certain set of standards your company follows to deliver the application to the customer. So CI/CD is a process where you automate all of these things, right? If you have to do all of these things manually, let's say you have to unit test your application every time, you have to functionally test your application, or perform regression testing on your application every time, even a single code commit that is made by developer, if you do all of these things, by the time your application reaches the customer, it would take months of time. But in the modern day, or these days, you are talking about delivering your application in weeks of time, or in days of time. So to achieve that, you have to have all of these steps automated, right? What are these steps? So some of the steps, okay, this does not have to be common across every organization, or this does not have to be common across every product, but some of the standard steps that you follow are unit testing your application, right? So you always have to unit test your application. You have to perform static code analysis. Don't worry, I'll explain about each and everything. You have to do some static code analysis. You have to do some like code quality or vulnerability testing, because for a customer you cannot deliver application with some security bugs, and then you have some kind of automation testing, like end-to-end testing of your application. Then you might have some kind of reporting for your application, right, where you store all of your reports, say that everything is working fine, all of your checks are verified, and finally you might want to deploy your application. This is mandatory, right? Without deploying your application, your client will not be able to access your application. So these are some standard steps that every organization has to follow. Without these steps, you are not sure that you are delivering a right application to your customer. Okay, so now let's try to understand what are these steps, each and everything, and then let us see how CICD will automate all of these things. Okay, so firstly, what is unit testing? So unit testing is nothing but, let's say you are writing a calculator functionality, or you are writing a calculator application where you are writing addition functionality. Okay, so whenever you are writing addition functionality, let's say you are writing this in Python, what you will do is, if you are writing code for a plus b is equals to c, so you will pass some arguments, like in your testing you will say pass 2 and 3 and verify that the output is 5. Okay, so this is nothing but unit testing your code. Okay, you are testing your code in that specific block, or you are testing the code with respect to that specific functionality. This is called as unit testing. Okay, every application developer has to do this, and this process cannot be manual, because every time the application developer is making changes to it, hundreds of times they cannot run this manually before delivering to the customer, or before submitting to the any staging, or promoting from one stage to another stage. Then you have static code analysis. So static code analysis, for let me give a basic example. Let's say that same example, I'm writing calculator functionality, and I've declared 20 variables, and I just use two variables. Okay, so the problem is there is a lot of memory allocation that is happening here, and you're wasting a lot of memory, right? So to avoid this, what we usually do is that we do some static code analysis to verify that you are syntactically right, you have well formatted your application. Okay, in some programming languages, formatting or the indentation is also very important, right? So you have to verify all of these things, like your application is well formatted, your application has all the indentation right, you did not declare any unnecessary variables, or there are a lot of other things. So this kind of things are called as static code analysis. Sometimes your code reviewer or your peer reviewer might not catch all of these things. Then you have code quality or vulnerability testing. That is, let's say you got a new version of Android yesterday, and you have upgraded the new version of Android, and today you came to know that there is a security vulnerability. There can be a hacker who can attack your mobile. Then that's a very bad customer experience, right? Or it's a very bad user experience. So before we deliver to the customers, or before we promote the environment, the application from one stage to another stage, what we usually do is that we do the code quality testing. And then there is automation, by which I mean to say automation testing. That is, in the first step we did unit testing. That is, we tested the feature, or we tested functionality of that specific function. To a plus b is equals to c, what we do is we pass 2 and 3 and see that 2 plus 3 is equals to 5. This is unit testing. Whereas you have functional testing. With functional testing, you will verify that the change that you have done, or the addition functionality that you have written, does not impact subtraction, multiplication, or division functionality. Okay, so you verify your application in an end-to-end manner. Okay, not just your function change that you have done, but end to end of your application you verify using the functional testing or end-to-end testing. Then you have some reports. These reports are very essential for any organization. Like tomorrow if somebody asks you what is your unit test coverage, how many unit tests passed, how many end-to-end tests passed in this specific thing, or what is the code quality thing, is it fine or not? So you need to have reports. Every organization has this, they store reports somewhere. And then finally you have the deployment stage. So deployment stage is for deploying your application onto a platform where your customer can access this application. So without that, no matter what you are doing, your application is not available to the customer. So these are some of the steps that every organization follows. And to do all of these checks manually, let's say you are doing all of them manually, you will take a lot of time to deliver your application to customer, right? Because it's always not like today you make a code change and you deliver your application to the customer. No, right? So what usually happens is, whenever you are writing an application or whenever you are writing a feature, you will not write everything in one step. What you do is you break them into chunks. Okay, so you create some Jira stories for each of the feature or each of the functionality, and you keep submitting them to your Git repository, right? So you store each and everything in your Git repository, and every time you are confident about a change. Let's say again, if we go back to the example, let's say I'm writing an addition functionality. I'll write first version of my addition functionality. Tomorrow I'll write version 2 of my addition functionality. Day after tomorrow I'll write version 3. Okay. Finally, eventually, maybe on version 10 or version 15, I might be satisfied about my addition functionality, and I'll say, okay, this version 15 has to go to the customer, right? So before that, whenever you are writing this version 1, version 2, version 3, version 4, all of them have to be stored in some place. In general, this is called as a VCS, version control system, or you know it can be any, I mean, VCS is a name, and the different tools for VCS are nothing but your GitHub or your Bitbucket or your GitLab, some of these tools, right? So your CICD is, or your CICD gets executed when you push your changes to one of these tools. Okay, so whenever this application developer is confident about version 1, what he does is he'll push this version 1 onto the VCS or version control system. From there, your CI/CD process will take care, right? Instead of manually executing all of these things, what will happen is, once you submit, once you're confident about your local changes as a developer, once you submit your changes to a version control system, then your CI/CD pipeline will actually take place. So what is this CI/CD pipeline? What are the tools? So let's start with the legacy tool and see how it will automate the process. Okay, so if we start from where we stopped, okay, so application developer again, so he is confident about the version 1 of the addition functionality that he has written. What he'll do is he'll submit that into a Git repository. Let's say it happens to be GitHub in our case. Okay, so he pushed the changes to GitHub. Now from here, all the things that we discussed should take place, that are unit testing, static code analysis, automation testing, blah blah blah. So what we will do is we will deploy a CI/CD tool. For example, we will deploy Jenkins in our organization, and what we will tell Jenkins is always watch for this GitHub repository, and whenever there is a pull request, or whenever there is a new commit that is made onto this Git repository on a specific branch, on a specific repo, okay, just tell me that there is a change that is made, and what I will do is I will run a set of actions. Okay, so what Jenkins will tell is notify me whenever developer is submitting any change onto a specific repo, onto a specific branch, and as part of the automation, Jenkins will run all of these steps that I have told you. Okay, the unit testing, static code analysis, and all of them. So how will Jenkins do that? Okay, I explained to you that Jenkins will do it. So what Jenkins will do is Jenkins will act as an orchestrator, or it will act as a pipe or a tunnel. Okay, now what Jenkins will do is that as part of this pipeline, tunnel, or you can consider anything, Jenkins will automate a lot of tools in it, or it will orchestrate a lot of tools in it. So these tools are, for example, if we talk about unit testing and building the application, what you can do is you can run them as part of, if it is a Java application, let's take Java application. So you can integrate your building of application in Maven and running unit tests using some JUnit or Jacoco for code coverage or code checking. Okay, so let's say you integrate Maven, which will take care of building your application and running your unit tests. And then Jenkins can also integrate something like Sonar for your code quality, code testing. Then Jenkins can integrate ALM, or any other reporting tool for reportings. So who will do this? DevOps engineer will install or configure all of these tools within Jenkins, so that they get run whenever your code is committed to the GitHub repository. We will also see that in tomorrow's video. Don't worry about it. So Jenkins pipeline is not at all difficult to write. We'll start with Jenkins pipeline, and then we will move to advanced tools that we have been talking about. Okay, and then for example, After this happens to be deployment, then you can integrate K8s or any Docker platform, or you can also integrate any EC2 instance or cloud based VMs. So these all things can be automated within your Jenkins pipeline. So that's why Jenkins is called as a orchestrator. Okay, what do we call Jenkins as? Jenkins is an orchestrator which will facilitate all of these tools. Okay, or it will integrate all of these tools within it by using Jenkins pipeline. Okay, so that's why Jenkins pipelines are very important whenever you are watching for any job description. Okay, or you are looking for any openings in DevOps. I'm pretty sure you must have heard this word called pipelines, or you must have at least saw this term called as CICD. Why is it very important? Because of all the reasons that we just talked about. Without CI/CD, your applications will be delivered to customer months after months you develop your application, right? So who is solving the problem, or who is ensuring your application is delivered within minutes or within hours? That is the CI/CD process. Now, we talked about Jenkins. So in Jenkins terminology, we call them as pipelines. Okay, so Jenkins pipeline is something that takes care of automating all of these tools and executing the actions that these tools do. Okay, once you integrate Maven, your thing is to, I mean, the pipeline should also integrate Maven, and it should also execute Maven. Similarly, Sonar, ALM, K8s, or any set of tools that we talked about. So with this, we'll improve the efficiency of your application. It will also, I mean, so this is step one. In step two, what you can also do is that, like, whenever you're again, you are an app developer, you are committing these changes onto a Git repository. Okay, so your Jenkins pipeline here can also, you know promote your application to different stages. Firstly, your application, Jenkins, can promote your applications to dev environments. Then whenever it is confident, what it can do is it can promote the application to staging environment, and finally it can promote to production. What is this process? Okay, so this is a very important thing. Stay with me, stay focused, I'll explain you in detail. So usually what happens is organization divide their environments to multiple things. Like, there is a production environment which is very similar to the I mean, it is very similar, or it is the exact environment that customers are using your applications. Okay, so in some cases you will use a pre-production environment, or in some cases you will directly use a production environment. So in terms of production environment, this is the exact environment where your customer is using your application. Okay, let's say here your customer is using application. So even though you perform all of the steps that I mentioned in the previous slide, there is a difference between the environment to environment, right? So what happens is usually the production environment will have lot of servers, or it replicates the exact setup where you are deploying your application to your customer. In staging, you might have less amount of CPU or less amount of RAM, and you want to deploy your application before every time you deploy your application to production. And dev is like -1 for your staging. So Jenkins can take care of deploying your application to multiple stages. Okay, so the reason why your application has to be deployed initially to dev platform is your QA engineers would firstly might want to, or your automation might want to execute initially on a simple environment, like a very simple EC2 instance. And once things are looking good, your Jenkins can automatically promote using some manual approval, or automatic approval. Once everything are looking good on the dev platform, you can do an automatic approval, and using this automatic approval, now application will be moved from dev to staging environment. So in the staging environment, like, instead of a simple EC2 instance, you might have a cluster here. Okay, maybe using auto scaling, you created two EC2 instances, or maybe you are using a Kubernetes platform where you have here you just might have one master and one node. Here you might have three masters and five nodes, or five worker nodes. And in the production, you might have some three masters and some 30 worker nodes. Okay, so every time before you reproduce this environment on production, or before you deploy your application on production, you might want to test it on a single node Kubernetes cluster, which is your dev environment. Then you might want to go staging, which is your three master and five node architecture. And then you might want to actually deploy to your customer. So why you cannot have production like environments even in staging is because this is a very costly setup, right? So your customer, you might give a very rich and robust setup, but every time you want to test it with your local testing team or your local QA team, you might not have that rich setup. So that's why you deploy your applications onto dev and staging environments, right? Are things clear till now? So if you have any questions till now or till this point of time, definitely post that in the comment section so that I can understand. Okay, at this timestamp you did not understand something. So please also put the timestamp so that I can take this as a constructive feedback and improve myself next time. Okay, so now once you understood all of these things, okay, so this is of Jenkins, which is a legacy tool. The reason why I'm stressing it as a legacy tool, I don't mean to say that Jenkins is not used these days, or I don't want to defame Jenkins, but the reason is that Jenkins has been a tool that is like, people started with Hudson, like I mentioned. So this was a tool that was used, like everybody might have started with Hudson or Jenkins if they are a DevOps engineers from 7 to 8 years back, and then people eventually moved to Jenkins. Okay, and everybody start dealing with on-premises first, and then they move to cloud platform. But these days everything is microservices, right? If you look at, for example, Twitter, or if you look at some applications like Flipkart or Amazon. So they are basically some thousands of microservices, right? They are basically some thousands of services. Now to deploy these thousands of services, okay, Jenkins is a platform. Tomorrow you will understand whenever we are deploying Jenkins. So Jenkins is nothing but it's a binary, okay? And what you will do is basically you install Jenkins on one host, probably your laptop or your EC2 instance, and then you keep adding machines to it because there are hundreds of developers in your organization, and one Jenkins node cannot take all the load. So what usually you do is you deploy your Jenkins master on one EC2 instance, and then you keep connecting multiple EC2 instance to it. And then you will say, let's say there are 100 developers, or then there are 10 teams. You say that, okay, for team one, every job that is running or every change that is made to your GitHub repository, run the pipeline on node 1. For team 2, run it on node 2. For team 3, run it on node 3, 4, 5, etc. Okay. Now the problem here is that this has to scale up, right? So if there are 10 teams in your organization, you might create some 10 Jenkins machines. Okay, and again for each development team inside that specific team, you might want to set up some additional VMs for running the nodes on specific, or running pipelines on specific nodes. So this setups become very humongous, right? Because every time you scale up these Jenkins instances, you have to create lot of compute. Okay, so compute is basically very costly. Even in during our virtual machines class, I explained you that compute is basically your RAM, right? Your CPU, and let's say your hardware. Okay, so this is your compute. Now when you keep adding compute to your Jenkins instances, the setup becomes not only very costly, but the maintenance also becomes very huge. Okay, so instead you should actually look for some setups which can scale up and scale down automatically. So people might ask one question here. Okay, I can integrate my Jenkins with auto scaling groups, and I can scale up and scale down automatically. But see, we are talking about some real time things, right? Let's say you have to scale your Jenkins to complete zero. I don't even want my Jenkins master node to exist. That is not possible, because there are times, let's say during your weekends, or during some odd times, there is no, I mean, there is some zero code changes that are made and zero pipelines that have to be executed. Okay, in case of thousands of microservices where you have some 20 to 30 Jenkins instances and 20 to 30 Jenkins setups. Okay, we are talking about 20 to 30 Jenkins master nodes, and again 3 to 4 worker nodes. So if you are not configuring them well, so at any given point of time, you have some hundreds of virtual machines which are created but not used. But my condition or my requirement is that I have to have zero servers when I'm not using any, or when I'm not making any code changes. So in such cases, Jenkins is not a tool that you should recommend. Okay, so let us see how these modern day applications, okay, let us take a look at one example, because these days most of this there are some applications that are highly scalable and they are open source. So let us take a look at one very popular open source application, that is Kubernetes, and let us see how Kubernetes is managing these things. because Kubernetes has some thousands of developers. Okay, they are in different parts of globe, and they usually communicate using GitHub, right? So let us see how Kubernetes is handling these things. Whenever a developer in India making a code change to GitHub repository of Kubernetes, how Kubernetes is dealing with the code change and how it is ensuring that it is not wasting the VMs that I just explained. Okay, so let me stop sharing this one and start sharing a new screen. Stop share, and then let me share my browser here. So this will be really interesting, and I would request many people who don't know the GitHub Actions or GitLab pipelines to just, if you have any questions, don't worry. I'll definitely explain these things in tomorrow's class, where you will be definitely able to understand the setup. So I have increased the font, and see here, this is the Kubernetes GitHub page. Similarly, you will have GitHub repositories or GitLab repositories in your organization as well, where developers will commit the code changes to this version control system. So if you see here, Kubernetes has 3,347 contributors that are developers. Now, anytime any developer might do a code change, but at this point of time, no developer is making code change because I'm not seeing any new commits to master branch, or I'm not seeing any new pull requests. So by the time I logged in, there are 761, and even now there are only 761. So let us see how Kubernetes is handling whenever there is a pull request or whenever there is a commit that is made. So if you go to the pull request, okay, so the last pull request was 4 hours ago. So for the 4 hours, there is no code change that is made, or there is no pull request that is made. So the expectation or the ideal scenario should be, for this 4 hours, okay, from past 4 hours, there should be zero compute instances Kubernetes project must be wasting. Okay, if not, you are losing a lot of money for your organization. You are wasting a lot of money for your organization. So if you see this pull request, what usually happens is they have configured it using GitHub Actions. Okay, so here what they are doing is they are running the entire thing using GitHub Actions. So GitHub Actions is another way of doing CI/CD, just like Jenkins. And what happens here is whenever a code change is made, it will spin up a Kubernetes pod, or a Docker container for you, and everything gets executed on the Docker container. And if you are not using it, then the server or the worker which is used to run these Docker containers will be used by some other projects, like you do a shared resources. So in the concept of shared resources, the advantage is that, so Kubernetes project, there are if you go to the Kubernetes organization here, there are some 77 repositories. Or if you are using GitHub Actions, and if you are using runner from GitHub itself, or if you are using runners from Microsoft, runners are nothing but worker nodes from Microsoft. So what Microsoft will do is that it will create containers for you, or Kubernetes pods for you, on the Microsoft servers itself or the Azure servers itself. So you don't even know where the servers are getting created, and if it is a public project or open source project, you will get it for free. So let's say you don't want to use Microsoft, okay, and your code is secure. What you can do is that, let's say for this 77 repositories, you can create one common server. Okay, you can host this server on Azure, you can host this server on AWS, or it can be Kubernetes cluster anywhere in the world. And what you can say is that whenever developer is making commit on any of these 77 repositories, okay, so what you will do is you can create a Kubernetes pod on this Kubernetes cluster, and once the execution is done, all of these steps are done, just delete the pod so that I'll be free one more time. Okay, then any other project can use that Kubernetes cluster. So what you have done here is, instead of wasting resources for each and every project, instead of creating Jenkins instances for each and every project, you can create one common GitHub Actions, which can be used across multiple people in your organization or multiple projects in your organization. And you can basically save your resources, save your compute. And if nobody is using it, there is no wastage, because the server size is shared across everyone. So literally you are using zero compute instances when there is no code change. So this is about your modern day CI/CD setup. I'll also explain you in detail whenever we are going to talk about future projects in tomorrow's class and day after tomorrow class. And one more advantage is that your solutions are extremely scalable. That is, today if you're using a Jenkins instance, every time you have to add one more server, what you will usually do is you keep adding one more worker node, or you just make any additional worker node and attach them to your existing Jenkins setup. Whereas in terms of Kubernetes, you all know that easily you can increase one more worker node, and you can scale it up to 100,000 or whatever you would like to. And if it is a managed Kubernetes cluster on EKS, or Amazon or something, you can directly add nodes, scale up these nodes or scale down these nodes. Right? Make sense? So this is some examples about CI/CD today. Basically, today we did not discuss practically about anything. I just wanted to show you one real-time project. So most of these open source projects use GitHub Actions. Okay, so one more tool that I wanted to introduce you. Many people definitely, whenever you watch the YouTube videos or whenever you start working with CI/CD for the first time, you'll definitely start with Jenkins. But you should also understand that there are very good alternatives. So there are projects on GitHub, there are projects on GitLab, there are projects on Travis CI, there are projects on Circle CI. So these are all alternatives, and these are all emerging CI/CD solutions. So even if you don't have good knowledge of how to implement them, one should definitely understand the alternatives. And eventually everyone might move towards it. Like if you ask me, I like GitHub Actions over Jenkins because of the reasons that I just explained you, right? For example, if I have to compare, let's say you'll ask me to compare, definitely in future I'll do a video where I'll compare Jenkins with CI/CD. But there are many advantages with actions, like they are event driven. Even Jenkins is event driven, but you can only configure pull request action using some webhooks, or whatever webhooks that GitHubs are supporting. But if there is no webhook configuration for Jenkins, by default it is not event driven, whereas GitHub Actions are default event driven continuous integration and continuous delivery solutions. And you can also, what you can do with GitHub Actions is you can integrate your pipelines from one project to the other projects as well. So there are many advantages that GitHub Actions provides you. And in tomorrow's class and day after tomorrow's class, we will try to experiment them on one project using Jenkins as well as GitHub Actions. So people also asking about are also asking about GitLab pipelines or GitLab CI/CD. So don't worry about it. Like we cannot cover all of them, but if you know GitHub Actions, GitLab CI/CD is very similar. Even if you take an example on GitLab, you can search for that on Stack Overflow or something. You'll find them exactly similar. Only thing is that there are syntactical differences and semantical differences. That's the only thing. Okay, so I hope you like the video today, and if you are waiting for tomorrow's video, just post that in the comment section. Share your feedback for me on today's video, and I'll be waiting for you in tomorrow's video. I hope all of you join tomorrow's video and perform a practical scenario. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.